which
Yeah.
everybody seems to be on at this point in the year. I actually like that, the Common Core standard that they, no matter whether you're taking Algebra 2 or pre-calc, everybody's covering conic sections at this point. So it's kind of nice for me. All right, let's see. Which of these is page 1? This must.
They're both the same page. I just couldn't get everything to focus into one page.
Okay.
So I could only get a certain amount to focus.
All right.
The top
See if the other one comes up a little bit better for the first few questions. Yeah, it looks like it probably will. Okay. So they're giving you these polynomials, and they're asking you to determine which conic section they are, classify the graph as a parabola, and sketch it. Okay.
Yeah.
And all of these are going to be essentially the same in that you're going to try to put them in the general format of whatever conic section you see that it is. And you essentially do it by completing the square, every one of them.
Yeah.
All of this writing that I see, is that yours or the teacher's?
That's my attempt at doing this.
Okay. So let's have
The ones I have most problem with are the hyperbolas.
Okay, let me just look at this first one. So you combine the x's, x squared minus 6x plus 9 plus y squared plus 4y.
And
then you didn't need to complete the square here. It was already in that form. This one you needed to add.
No, that 9 is completing the square. There's a 9 after that equal sign.
Here, let me.
Where I rewrote it.
Let's write it on a piece of paper so I can figure out exactly what we have here. Just do the first one, and then we'll go to the ones that you have difficulty with. You just want to make sure you're doing the first one okay. This is what it started out with, right?
Yep.
Okay. And we know it's a circle because it has an x squared, it has a y squared, there's a plus sign in the middle, and they both have the same coefficient. That's the key. If there was a 3 in front of this one, then it would be an ellipse. The only difference between a circle and an ellipse is the coefficients are different. So typically, I would do it like this. And I would take that 9 on the other side of the equation.
Yeah, that's what I did.
Okay, cool. And then you complete the square. What goes here?
9.
Which means I have to add 9 over here. What goes here?
4.
So I have to add 4 over there. Now I have x minus 3 quantity squared plus y plus 2 quantity squared equals 4. So now, since I know it's the equation of a circle, I can graph it. Where's the center?
3, -2.
Right there. What's its radius?
Oh, God. That's the radius.
This is the radius squared. Whatever.
Okay, so it's So it's 2?
Correct. In other words, whatever is on the other side of the equation line, the standard format for a circle is x minus h squared plus y minus k squared equals r squared. It's the only one that's equal to r squared.
Okay.
Okay? Notice the ellipse. It's got an x squared and a y squared. It's pretty much exactly like the one, number 1. The only difference is the y squared has a 4 in front of it, the x squared has a 1. So it's going to go into the standard format for an ellipse, which is x minus h quantity squared over a squared plus y minus k quantity squared over b squared equals 1. Now, do we need to go through number 2? At least one ellipse?
Yeah, let's just do it.
All right. Hyperbola is coming up next. Hyperbola presents just a little extra problems. But an ellipse, I'm going to go ahead and rewrite this as x squared minus 6x plus 4y squared plus 16y. Leave room to complete the square equals negative 21. It's the first thing I have to do on the left side.
Add the 9.
What do I have to do on the right side?
Take out the 4.
Yeah, you cannot complete the square until the coefficient is 1. So I have to factor out a 4. So this becomes and now how do I complete the square?
Add 4.
How much did I just add to the left side of the equation?
16.
So I have to add 16 over there.
Okay.
Okay? That's the key. Whenever you've had to factor out, it's not this that you add to the equation, it's that times whatever you factored out. So now I have x minus 3 quantity squared plus 4 times y plus 2 quantity squared equals, what is this, 4? And the next step.
Is it divide both sides by 4?
Yeah, as soon as I've recognized that this is an ellipse, my next goal is to turn that into 1. And I do that by dividing both sides of the equation by whatever that number is. So now I get x minus 3 quantity squared divided by 4 plus y plus 2 quantity squared equals 1. And that is the standard format for an ellipse. Tell me where the center is.
It's 3, negative 2.
Tell me what A is.
A is 2.
What's B?
B just 1.
Correct. Which makes C what?
Square root of 3.
Good. Now I have everything I need to graph it. Is that a horizontal or a vertical ellipse?
That is a horizontal.
Yeah, let me graph it just a little different here. So the center is right there at 3 comma minus 2. And it's horizontal, so I'm just going to graph a horizontal ellipse around it. A is this dimension. What is that? 2.
Isn't it? Yeah, 2.
Yeah, we figured it out already. B is that dimension, which is 1. And C are both of those dimensions. So let's start. Whenever you're talking about an ellipse, you have 7 key points. You have the 2 major vertices. You have the 2 minor vertices. You have the center, and you have both foci. Give me the coordinates of all of these. What's the coordinate of this major vertice?
Isn't it 5, -2?
And this one over here?
That one is 1, -2.
Yeah, and if my graph doesn't agree with that, it's okay. As long as we get the label right. In other words, obviously I drew my graph too big, right? I should not have drawn it so that it crossed the y-axis. But that's not really important as long as we have all the numbers right. And coordinate on that?
3, -1.
And the coordinate on this one?
3, -3.
And the foci, that foci and this foci.
It would be 3 minus √3, and then -2, and then it's 3 plus √3, -2.
Yeah, and those kind of answers are exact. In other words, as tempted as you might be to want to take 3 minus √3 and turn it into a number, you can't do it unless you want to approximate it. That is the proper answer. The coordinate of the foci on the left is 3 minus √3. It's not some decimal, okay?
Right.
I'm sure they're looking for exact answers. So,
Yeah,
and this is an exact answer. It's not an approximation. Okay, so it looked like you handled the ellipse just fine. Let's talk about hyperbolas. They introduce one extra problem that is serious in the sense that everybody tends to make this mistake. Why is this a hyperbola?
because it has a negative squared number.
Well, both the x and the y are both squared, and they're separated by a negative sign, as opposed to a positive sign. If I make that a positive sign, that's an ellipse. But if it's a negative sign, it's a hyperbola. If it's x minus y, is it a horizontal or a vertical hyperbola?
I think it's a
horizontal, like that. If this were y squared minus x squared, it would be a vertical, like that. That's the only thing that separates vertical from horizontal, is the sign that separates x squared from y squared. Okay? Now, this is a little tricky in the sense that when you set it up to complete the square, you have to add parentheses, just like normal. But in this case, there's a negative sign there. What else do I need to put over there?
Is it just
there's no y term. Oh, it completely destroyed my argument. So it's just like this. In other words, you would do this. This would have been a better problem if it would have had like a plus 6y. You understand
when you
what I'm
put
saying?
yeah.
Okay,
Yeah.
let's do that problem. Let's do this problem. There's a plus 6y in it. What do I
Okay,
have
so
to
you'd
write
add
over here?
would you add a negative 6y?
Yes, that's the secret, is you have to change the sign. Because this negative sign has to be distributed to both terms, and I've added parentheses. So the key is to never change it. In other words, this bottom equation is identical to this top equation. And that's what you want. And most people, the mistake they make is putting the wrong sign. They make that plus 6y. And then, of course, the plus 6y gets turned to a negative because of that, and you don't have what you started with. Okay? And then the rest of this follows. I would factor a 4 out, complete the square. I don't have to factor anything out at all there to complete the square. All right. Let's go back and deal with the problem that they gave us, which is this one. Let's finish that.
So factor out the 4 of the first one.
What do I?
And then is it 1 plus 1/4 or?
No, you got it. Perfect.
Okay.
Take half of that coefficient and you square it. Well, half of 1 is 1/2. 1/2 squared is 1/4. How much do I need to add to the right side?
1.
So now we have 4 times x what? How do I write this term as a linear term squared?
Is it just x minus
Whatever you
1/2?
got before you squared it, whatever you got, it was 1/2, right?
Yeah.
That's what it always is.
Okay.
Next step?
Then you divide both sides by 4.
Now, you know it's a hyperbola. Where's its center?
Is it just
Have
1/2?
Have confidence, Mitch. You know this. You don't need to ask me, is it?
It's 1/2 0.
I know you know it. What's A?
2.
A is 1.
What?
You see why A is 1?
Yeah.
What's B?
2.
Okay, and C, remember this is a different formula for a hyperbola. It's the same one you use for the Pythagorean formula.
So that's square root of 5.
Okay. To graph it, we start at our center. We know it's a horizontal parabola because it's x squared minus y squared, not y squared minus x squared. Now, the next thing you do when you're graphing a hyperbola is to draw this imaginary rectangle. Okay? And
Yeah.
this imaginary rectangle is 1 unit from the center to the right, and it's 2 units from the center up. So I'm going to put it in dotted lines. What's that vertex right there?
It's negative. Wait, is it 1 1/2?
3 halves. Let's use ratios.
0. Yeah.
Okay, and then this one over here.
That one's negative 1/2. 0.
Okay, and then this one up here, that's not really a vertex because this thing is going to look like something like this. So you might wonder, well, why do we even need this point up here? Well, because in order to draw the hyperbola, I really need the diagonals of that rectangle. So let's erase the hyperbola that I drew. What is this point right here?
1/2 and then 2?
Correct. So we actually have a rectangle that's higher than it is wider, which is okay with hyperbolas. In other words, B is greater than A, no problem at all. Okay, now I'm going to put my diagonals through there. In other words, now we kind of have the grid that we need to draw our hyperbola. And the key is the hyperbola has to go through the major vertice, and it's going to be asymptotic with that diagonal. So I can't really graph it until I've drawn this rectangle and the diagonals. So that's the graph of it, and all of the key points. And you don't necessarily need the coordinates of that, but you definitely need to know where the top of that rectangle is. In other words, that rectangle is at y equal 2 on top and y equal minus 2 on bottom. And that is important because you can't draw the diagonals until you've drawn the rectangle, and you can't draw the hyperbola until you have the diagonals.
All right.
Okay? Let's find something a little harder. Maybe a hyperbola that goes vertically and has a y term. Let's do a parabola before we do that. Well, hold on a second. Maybe not. Let's do number 5, and then we'll do number 4.
All right.
Since we're talking about hyperbolas, let's do this hyperbola. Why is this a hyperbola?
Because it has a different sign.
What if I had that? What would it be?
Would
words,
that be an ellipse?
If I put, yes. In other words, if I have 2 negative signs, if I have a negative sign in front of the y squared and in front of the x squared, well, my first step is to divide everything by minus 1, and then I have y squared plus 4x squared, which is an ellipse. Okay? So, and sometimes they'll get tricky and give it to you like that. Okay, so let's separate this, getting it ready to complete the square. What do I have?
y squared minus 2y. And then the negative sign. And then 4x.
Yeah, let's do it step by step. Let's not do that factoring at the same.
Yeah, 4x squared. And then minus 4x.
Good.
And then equals to 4.
Okay. Now it's pretty much like every other one we've done. What do you put here?
1.
Plus 1. It's always a plus. What do I do over here?
Factor out the 4.
And then add
1/4.
Okay, the plus 1 that I added, I forgot to write it over there. How much do I have to compensate for the 1/4 I just wrote in there?
Would you do -1?
Uh-huh. So now rewrite it as the next step.
So it's y minus 1 squared minus x.
Minus 4. We factored out that.
Yeah, minus 4. Yeah. And then x minus 1/2
Uh-huh.
squared, and then equals to 4.
And the next step.
Divide both sides by 4.
Okay. We already know that it's a horizontal parabola or hyperbola looking something like that. Where's its center?
Is it -1/2 1?
1/2 1.
It is 1/2 1?
Yeah,
Okay.
in other words, both of them, this is x minus h, and this is y minus k.
Yeah, but I'm just confused by the negative with the square.
That means it's a hyperbola. It does not affect anything else.
Oh, okay.
Okay? It's still always y minus k and x minus h. In fact, on all of your conic sections, it's x minus h and y minus k. It's never plus.
All right.
What's A?
Is 2.
Correct, because A is always measured along the major, excuse me, I drew this wrong. Sorry about that. It's vertical, right?
Yeah.
When you have a hyperbola, the point that connects your vertices is the major transverse axis. A is always measured along that. And B is always the other thing. So sometimes A is measured horizontally, sometimes A is measured vertically. If it's measured vertically, it's whatever's under the y term. If it's measured horizontally, it's whatever's under the x term. So A is 2. What is B?
1.
And C?
√5 again.
Yeah, these numbers come up a lot. In other words, they get repeated a lot. So if all I have to do is make sure that my center, here, let me redraw it a little bit. Give myself some room also. Let's draw it down here. Start with the center, which is right there. 1/2, 1. And when you're graphing hyperbolas, there's really only one method you can do. And that's start with the center, then draw your box, then draw your diagonals, then draw your hyperbola. Okay? What is the coordinates of that point right there, the top of the box?
5 halves, comma 1.
Good. Well, notice the x-coordinate has to be the same. I'm going up.
Oh, okay. So.
Even though a is going to be 1 plus a, so this is the 5 halves. That's 1 half. This is 5 halves. In other words, I'm adding. So hold on a second.
No, it would be 3.
You're right. It's 3.
I don't know.
Okay. And this point right there is what?
That is 3 halves.
Correct. Comma.
And 1.
Yeah. So we know now how that box looks. Now the rest of it is to just draw the diagonal. Have they asked you about the equations of these diagonals?
They did on the quiz, but I didn't hear her ever explain how to do it.
Well, notice that those diagonals are straight lines. What's the slope? What's the slope of that diagonal?
Is it just A over B?
Correct. Now, that tells me a lot, and there's an equation for the slope of that diagonal also. Not A over B, but once you know the slope, figuring out the equation of the diagonal is not that hard. There is a formula for it, to be honest. I don't remember exactly what it is when it's not at the origin. If it's at the origin, in other words, if my center was at 0, 0, then the slope of this line is A over B, the slope of this line is minus A over B. When it's at the center, it's a little harder.
When it's not at the center, you mean?
No, when it's at the center, it's really easy. It's just A over B.
Yeah, you said when it was at the center, it was harder.
Well, so this one is not at the center. So yeah. The equation of this diagonal is not just A over B, which is the slope. You look it up.
I think I may actually have it right here.
Yeah, what is it?
Is it plus or minus A over B, and then parentheses X minus H plus K?
Yeah, that sounds right. And it's Y equals that?
Yeah.
Okay. And yeah, with H and K being the centers. So in this case, the equation of the diagonal with the positive slope is what?
2, and then parentheses X minus 1/2 plus 1.
Correct. That's the equation of that line, that diagonal. And they might ask that of you. Okay. That's the hardest part of conics, is the equation of the diagonals of a hyperbola. Mainly because they don't always get that far in school. In fact, I'll have a lot of students that they'll never have to know that. But if you do have to know it, then you kind of have to memorize that equation. Notice that it's not that easy to figure out otherwise. In other words, I can figure out the slope really easily. But figuring out the rest of it, the x minus h plus k, you have to incorporate that. If the center is anywhere, notice that if the center were at 0, 0, then the equation of that line would be a over b times x. Y equal mx plus b. Well, different b, but I think you understand what I mean. All right. Now let's do parabolas. Because parabolas have their own uniqueness to them. Why is this a parabola?
Because it only has one square.
Yeah, only one variable is squared. The x variable is not squared, the y variable is, which makes it a parabola of this form. Right?
Yeah.
What's the parabola you've learned for 3 years in algebra, geometry, and algebra 2? What's the
Y equals x, x squared.
Y equal x squared. So this is the parabola that either goes up or goes down, right?
Yeah.
Which means x equal y squared must be the horizontal parabola. It either goes to the right or it goes to the left. Positive coefficient goes to the right, negative coefficient goes to the left. Just like the vertical ones, positive coefficient goes up, negative coefficient goes down. Okay, so this is a sideways or a horizontal parabola because we have the y squared and we have x. Now, let's talk the general format for a parabola. First of all, if we go back to your Algebra 1 class, this is the general format. We were only dealing in vertical parabolas that either went up or down. And this is what they taught you. That's the vertex format for a parabola. When you get to conic sections, they change it. They move the k over to the other side, so you have y minus k equals, and instead of putting the a in front of that, they put a 4p over here. So you could always use this format and a is equal to 1 over 4p. But it's easier if you don't do it that way, if you start with their proper general format. This is the proper general format for a horizontal parabola. P being what?
Is it the focal width?
So the focal, it's the distance from the vertex to the focus. So if I have a parabola that looks like this, and I have a focus right there, this distance right there is P. Okay? And the directrix is always the same amount away from the vertex as the focus is. So this distance here is also P. In fact, the definition of parabola takes on a whole new definition when you get into conic sections. The definition of a parabola is the locus of points which are equidistant from a focus and a directrix. Meaning if I have a point anywhere on this parabola, the distance to my focus is exactly the same as the perpendicular distance to that directrix. No matter where it's at, even if I'm way up there, that distance equals that distance. So we're learning all kinds of things about parabolas that we didn't know before. In other words, this original definition, first of all, only applied to vertical and horizontal parabolas. and it didn't talk about focus at all. The reason they've changed the format on you to this is because if I can put the equation into this format, I immediately know my focus because I got P right there. Okay?
Yep.
So let's try to, instead of putting it into the original general format, let's put it into this format. Well, let's move all the numbers over. So I have y squared minus 6y, and I'm going to move the 4x over, like that.
All right.
Always make sure you've never changed it. Hold on a second here. Okay, let me go back. I made a mistake here. In this case, that's the squared term. And the 4p always goes in front of the term that is not squared.
All right.
So that's the general format for a horizontal parabola. Y minus k squared equals 4p. Just remember to always put the 4p in front of the non-squared term. Okay, now let's make our equation look like that. Well, if I complete the square on the left, I'm going to add how much?
I'm going to add 9.
I'm going to add 9 on the right to make up for that. And now I'm going to go down here and turn this into y minus 3 quantity squared equals 4p times, well, let's see, what is that? Minus 12, 4x minus 12?
Yep.
So if I factor out a 4, I'm left with x minus 3. Same so far? In other words, this is the same as this. That's the key. Every time you do a step here, you should always kind of check to make sure you haven't changed the equation. This is the exactly same equation as that. Okay?
Right.
Only I'm getting closer and closer to this format. I've got the y minus k. I've got the x minus h. The only thing I have is a 4 instead of a 4p. So what is p equal to?
Is p equal to just 1?
Correct. In other words, I can equate that and that. So I can say 4 equals 4p, p equals 1. Now I have everything I need to graph it.
All right.
Where's my vertex?
It's at 3, 3.
Okay. Does it open to the right or to the left?
It opens to the right.
That point is 3, 3, and my focus is where?
Is that
Coordinates?
7, 3, or is it?
What was
just
p? What was p again?
P is only 1, so is it just 4, 3?
And the only other thing we care about here ever is the directrix. What is the equation of the directrix?
Isn't it just x equals 1?
2.
Oh, yeah, 2.
In other words, it's the same distance p as the focus is from the vertex. And the vertex was at 3, 3, so it has to be 1 to the left of that. So it's a vertical line whose equation is x equal 2. And you'll notice there really is nothing else about that parabola that we need to know. In other words, we don't really need to know any other points. We know the vertex, we know the focus, and we know the directrix. So the whole key is to put it into either, confused you a little bit, let me write the raw formats. Remember, we have either y equal x squared, which becomes y minus k equals x minus h quantity squared. Where's the 4p go?
It goes in front of the y minus k.
So that's the standard for a vertical parabola. For a horizontal parabola, we have the x minus h, and it's going to be the y squared, because x equal y squared is a horizontal parabola. Where does the 4p go?
In front of the x.
Those are your two general formats for parabolas. And whatever polynomial they give you, you have to put it into this by completing the square and moving stuff around. And then whatever the coefficient is over here, divide it by 4, and you have p.
All right.
And if you end up with a positive or a negative p, that merely means which direction you go. In other words, in our case, everything was positive, so I knew that p was to the right of the vertex. But if I solve this equation and I get p a negative p, it merely means that I have a parabola that goes this way. And to get to the focus, I got to go to the left. So that would be a negative p. If you haven't picked up on which way your parabola goes, to the right or the left, that will tell you. P will be positive for a right-facing parabola. It'll be negative for a left-facing parabola. See if they have any really good ones. Let me see. That's a circle. That's a piece of cake. Parabola, what kind? Horizontal or vertical?
That one is a vertical.
Always remember the very first one you ever learned, which is
Yeah.
y equal x squared, right?
Yeah.
Which is vertical. This got a y in it and an x squared, so this has to be a vertical one also. That's an ellipse, because the coefficients are different, and there's a plus sign. This is an ellipse, because the coefficients are different, and there's a plus sign. This one's a hyperbola, because there's only one minus sign. In other words, one of the squared variables is plus, one of them is minus. That makes it a hyperbola. Is that a horizontal or a vertical hyperbola?
That is a horizontal.
Now, the way to remember it is if it's x squared minus y squared, that's your standard horizontal one.
All right.
If it's y squared minus x squared, that's your vertical one.
All right.
This is y squared minus x squared, so this is vertical. What is 11? It's a parabola. Is it a vertical or a horizontal one?
It is a vertical.
Okay. I'm going to give you one really tough problem. See if you can figure it out. You may or may not get it on the test, but it's kind of an interesting one anyway. What kind of shape is this?
That's a ellipse.
Good. Where's its center?
Is it just 0, 0?
What's A?
Is it 1/16? Or is it
Very good. Well, the square root of 1/16, right?
Yeah.
In other words, if I want to rewrite this, most people have a lot of difficulty with this. They don't see any denominator. And I can't divide by this number over here because it's already 1. So I have to rewrite this, and the way you rewrite it is to divide top and bottom by 9, which gives you 1/9 in the bottom, not 9. In other words, when people want to rewrite this and divide top and bottom by 9, they want to write that. Well, clearly that's not the same as that. But if I put a 1/9 there, it is the same.
All right.
Do the same thing over here. You have y squared divided by 1/16. So it's an ellipse. A is always the bigger number. So actually you were wrong when you said 1/16. What is A? In an ellipse,
yeah.
A is always bigger than B. So you just have to find out which denominator is bigger, and that's A.
Yeah, so it would be 1/9.
1/3.
Or
Square root of 1/9.
Oh yeah, square. Yeah.
B is 1/4.
Yeah.
Okay. And since A is bigger than B, and well, actually I should say, since A is under the x-axis, it has to be a horizontal ellipse with that being A and that being B. Notice that A is always bigger than B in ellipses. Even if it's a vertical ellipse, A is now measured there. B is measured there. So by definition, A is bigger than B. So if you want to figure out whether it's horizontal or vertical, figure out which is the bigger denominator, and it's on that axis. 1/9 is bigger than 1/16, therefore it's on a horizontal axis. This is the picture.
All right.
Like I said, you may not see a problem like that, but if you do, you'll have a chance to get it now. You sent me 2 pages, right?
Yeah, the other one was just.
The other one's just the same page, yeah.
Yeah, it was just the same page. That's the same one we were just looking at.
Right. Okay. What is, again, they may not give you a problem like this, but what if they said, what is that?
Do you divide both sides by -2?
No, that is what is called a degenerative conic. In other words, this can't exist, right?
Yeah.
That's always a positive number, right? Whether x is negative or positive, that what I've circled is a positive number. I'm adding another positive number to it. There's no way I can get a negative number. You cannot add 2 positive numbers together and get a negative number. So this would have imaginary solutions only. But they're what are called degenerative conics, where it you end up with negative signs where you shouldn't end up with them. You don't ever, even if it looked like an ellipse, say it was something like that, if I had a -4 over there, cannot deal with it. If I tried dividing everything by negative, well, now I get this. That's a degenerative ellipse. Actually, it looks more like a hyperbola now, right?
Yeah.
But you can never have negative denominators, because remember, the denominators are always either a squared or b squared. So this is nothing. That is a degenerative either hyperbola or ellipse. I'm not sure which, but I can't draw it. And you're not going to see stuff like this probably. They may throw in a bonus question like this just to play with your mind a little, just to make you think a little harder. So if I had this, what's the first step? What is this object?
That is a ellipse.
Okay, what's the next step?
Do you just divide both sides by 144?
That's exactly right. In other words, your first goal is to always get that right side to 1. Now what do I have?
Now you have, it's just over 9, and then the other one's over 16.
And look at these numbers, because you're going to see these numbers again, where you have a 16, you have a 9, and you have a 144. It's a very, very common conic problem. And it's because 9 and 16 are factors of 144, and they give you perfect square numbers like I've got. So
Right.
A is, what is A?
A is 4.
B?
3.
Correct. What kind of an ellipse is it? Vertical or horizontal?
It is horizontal.
Remember, the A is now under the Y.
Okay, so it's,
So the long axis has to be along the y-axis.
okay, so
In other words, that's measured along the y-axis. The B is measured along the b-axis. So if the y has the bigger number under it, then that's A. And it's a vertical ellipse. Switch these two around, and it's a horizontal ellipse. Switch the two denominators around. All right, that's pretty good. It's rare that I've covered conic sections in full in 1 hour's time. Although I think we did conic sections last year. They usually give you a little bit of conic sections every year.
yeah.
And it's just they get a little bit harder each year. But I can't think of anything else about conic sections that you would need to know. Probably the hardest question they can possibly ask is, what's the equation of the diagonal? So memorize both of those, because the equation is different depending on whether it's a vertical or a horizontal hyperbola. There's two equations. They're very similar, but make sure you know the difference between them. All right, Mitch, good luck. I'm sure you'll do fine. You appear to know conic sections very well.
Yeah, this is going to help a lot, just going over just the simple stuff.
Good. We have a session next week.